So that's this bit. Let's understand what is demand and what is supply. So very simply put, the willingness and ability of consumers to buy a certain quantity of good at or a service at a given price is the demand for that good. The demand captures the buyer's action or behavior through something called as the demand function or its inverse, which is the demand curve. We'll see how this is used in the price quantity graph. Fine. What is supply? The supply is the willingness of sellers to offer a certain quantity of a good or service at a certain price. The supply captures the seller's action or behavior with the help of a supply function or its inverse, which is called as the supply curve. Fine. We'll explain and understand this as we go along, both the demand curve, supply curve, and the functions. So a market is typically made when buyers and sellers arrive at equilibrium quantity and price. What is equilibrium price? Is when the buyers are willing to buy the same quantity at what they think is the supposedly lower price, which the sellers are willing to supply at what the sellers think is a supposedly higher price. Correct. So a seller is happy because he or she believes that this is a great price they are getting for the product they are selling, and the buyer is happy because they believe that this is the best bargain they can get in terms of buying it. That's where the equilibrium gets established. That's where the trade happens as such. Correct. Now, equilibrium quantity is found when the highest price that buyers are willing to offer for a certain quantity is equal to the lowest price at which sellers are offering the same quantity. So let's say I want to sell 10 kgs of rice, and the lowest price I'm willing to accept is, let's say, $1 per kg. So that brings me to something like, let's say, argument's sake, close to $10 is what I want for 10 kgs of rice. The moment I find that and the highest price, let's say, that a buyer is willing to pay is $9 for the same amount of rice to be bought, then either I will lower my price or they will increase their quantity bid to eventually arrive at the equilibrium quantity. So let's say both of us agree at 9.5. That's the highest price the buyer is willing to pay, and that's the lowest price which I am willing to offer or accept. That's what is called as the equilibrium price, and that is where the equilibrium quantity will get arrived at. Fine. Now, typically buyers are willing to buy more quantity at lower prices, and sellers are willing to bring more quantity into the markets at higher prices than the equilibrium price. Fine. Let's then move on to the demand function, which captures what is a quantity supplied for a particular goods or service depending on various parameters, right? So let's understand the equation first. The left hand side of the equation talks about the quantity that is quantity demanded. I mentioned quantity supplied, but this is quantity demanded by the parties who are the buyers. That's why it's called the demand function. So quantity demanded of the good X is denoted by QXD. This is the equation, that's a linear equation that we are assuming here, that depends on some constant and three variables as we have outlined them. The number of variables in reality could be higher, but to keep things simple, we start with three broad variables. Px is the price per unit of the good X for which we are looking at the demand. I is the consumer's income, and Py is the price of another good Y. Correct? So let's say the price of petrol would depend on the quantity demanded of petrol would depend on the price of petrol, my income as a buyer, and the price of diesel as well. Correct? Because that's how effectively, if the price of diesel goes up, then what happens to the quantity demanded for petrol? That also becomes an important part of the equation. So let's also look at the signage here. So effectively, if we look, there's a negative sign, which means if price of good X goes up, quantity demanded should go down, which is logical. That seems to be logical in reality for most goods in real world. If the income goes up, typically my quantity demanded should go up. That's also true for most goods in real world. Now, this could be either plus or minus depending on what product we are looking at and what kind of sign accompanies that product. We will discuss this in more detail, but here we are saying that another goods price is also negatively impacting the quantity demanded of good X, which means if the price of this Y goes up, the quantity demanded for X actually goes down. Now, when would that happen? Is when Y and X are effectively complementing each other. So let's say you have something called as, let's say we're looking at prices of DVDs and prices of DVD players. If prices of DVD players goes up, then quantity demanded for DVDs will go down. Correct? Because logically you'll have lesser DVD players. So these are to be used together, and hence you find a negative sign. If you find a positive sign, these are typically substitute products. More on this as we go along, so we'll take that into consideration as we look at it further. Now, this what we see is the demand function. Typically, when you're plotting on the price quantity curve, what you find on the vertical scale is price, and what you find on the horizontal scale is quantity. So effectively, if you're plotting a curve like this, that's where price is, that's where quantity is. So you want to create an equation of P is equals to something of Q, whereas what we have is Q is equals to something of P. Correct? So that's the function that you want to kind of calculate. So the first things you want to do is you want to probably freeze a couple of items. So this at this point of time has a lot of elements into it. It has income, it has price of some other good. So we probably want to kind of eliminate two of the three independent variables. So how do we do that? We keep them constant. So we fix the, let's say the income. So 2 out of the 3 variables that we have, we will fix the income and we'll fix the price of Y. Once we fix these, then essentially both these become constant and get added to this item. And then we have a clear relationship between quantity and price. Correct? So that's what we're going to do in terms of fixing them. Remember, we are not ignoring them, we are fixing them. So let's remove the consumer's income from there. Let's then remove the price of the other good from there. And by holding the consumer income and price of good Y constant, we would focus on the quantity demanded and the goods zone price. The other variables are, remember, not ignored but combined and added to the constant. So let's assume you put in some price point for the income, you put in some price point for the good Y, and let's say you get this equation. So you added that 50 based on whatever numbers you got. That 10 has become 50 now, correct? Now we still have what we call it as the demand function, from which we need to come to demand curve. Demand curve, remember, needs to have price on the left hand side and quantity on the right hand side. So we just need to switch it essentially. Now we'll invert the demand function to get the equation to make the demand curve. How do you invert it? So effectively first we rewrite it like this, and then we effectively find out what is it that we need to divide by. So we can divide both sides of the equation by 0.4 to arrive at Px is equals to something minus Q and a function of Q, or whatever the number we'll look at as slope of Q that will come in, correct? So that's how you would invert the demand function into demand curve. So we do this and then we realize that 0.4 goes away, and what we have is price is equals to 125 minus 2.5 Qx. How did we get this? If you remember, we divided both sides of the equation, which was 0.4 P is equals to 50 minus Q. We divide both sides by 0.4 and we get 125 minus 2.5 Q. The negative sign shows that the price going up would result in quantity going down. Now we can plot it. Once we plot it, we effectively get this kind of a curve where we have you can keep quantity as 0 and then try and find out what is the maximum price that you would be willing to pay for it. Then you can keep quantity as price as 0 and find what is the maximum quantity that would be sold. That would come here. So effectively we are saying quantity is equal to 50 at this equilibrium point, at the point 0, correct? That's my demand curve.